Hello everyone and welcome back to my channel. Today I'm going to give a brief progress report on my Arduino security light project. For more context, please refer to my last video that I uploaded. In my design course, we're currently in the testing phase for our projects, which has involved fine-tuning the operation of the components within the circuit and transitioning from a traditional breadboard to a soldering board for a more permanent installation of the connections. I'll be focusing on this in the video today. In this latest design phase, the circuit has not changed since its implementation in the last video. However, I have made some changes in terms of the organization of my wiring. This time around, I have ensured that for soldering, I have made one board dedicated to my sensors with ample wire length to fit in my future box. I have scored and split a second soldering board dedicated to my LCD screen, which requires several wires to operate. Aside from this organizational change, my components and wiring remain the same. Again, you can see my relay, PIR sensor, LDR, and button connect to a single board and interface with my Arduino. The other side of my relay connects to my light bulb. Let's observe that the board is still functional as it was before in my previous video. So as you can see in this first clip, when I go to press the button, the LCD screen will display the battery charge level. It will also trigger the relay, which serves as my ability to test input. Additionally, just like my original prototype, the motion sensor remains off when motion is sensed in high light conditions, like at the start of this clip. However, when I place my LDR into the dark center of this coil of solder, my motion behind the camera triggers the PIR and flips the relay. Once this new soldered board was working as expected, I had the opportunity to do some testing and calibrate my components and circuit. After testing my LDR in a variety of lighting conditions, the LDR threshold that consistently activated the PIR sensor was an LDR threshold of 500. This particular LDR sensor has its voltage divider configuration, where in low light conditions, the voltage at the analog input pin is high, and thus when the LDR exceeds a threshold of 500, the circuit allows the relay to flip. I also had the opportunity to fine-tune my battery voltage charger parameters based on real-life performance. After some testing, I discovered that the LED began to flicker and would fail to display the battery charge level when the 9-volt battery dropped to about 6.5 volts. Therefore, I included this new value in my equation for determining the battery charge for more accurate representation of the charge level at any given time. As discussed in my last progress report, I found that my circuit was pulling closer to the range of 1 milliamp hours consistently on the graph above, meaning that the battery will have a longer life and least sharp decline in discharge capacity compared to if I had decided not to implement low power mode in my code. The one remaining component I intend to test further is my PIR sensor. Although it works as expected, I intend to adjust and calibrate the range of the component to its maximum so as to detect motion as far as 7 meters away according to the datasheet. In the following video, I will include final testing information and present the final product in its packaging. The packaging will now look slightly different than it did originally. A 3D printed box may no longer be viable, and the new soldering boards have different dimensions and wire organization. This model here provides a general idea of how the components will fit into the box, with sensors exposed through cutouts in the Arduino and wire connections inside, with the light bulbs matching to the box exterior. In the next video, I'll go into detail on the final product. Thanks for watching.